Mainly computer has been invented for the purpose of calculation. Then which is the first calculating machine? That is abacus. Who invented this napier bone? It was invented by the Scottish mathematician. His name is John Napier. When it comes to the starting point, that will be directly proportional to the logarithm of a number printed on the rule. When it rotates or when it revolves one side, so that control will be moved to the next wheel or next dial. Hello everyone, welcome to the second session on overview of a computer. Myself Rohini TS, lecturer in computer science, Vidhyaashram Pre-University College, Mysuru. So before getting into the today's session, let me have a recap of previous session. So in previous session, we had a discussion regarding what do you mean by computer. So as I told or as I discussed earlier, computer is an electronic machine which has the ability to store, recall and process the data as per the requirements of user. So when it comes to the characteristics of a computer, so what was the code that I have given for that? In order to get to know the characteristics of a computer, we have to follow some code like SMS, AVA, CD. So this will help you out in order to remember the code, that is storage, memory, speed, automation, versatility, then accuracy, cost effectiveness and elegance. So these are the characteristics of a computer. Then when it comes to the data and information, so data are nothing but it is a raw facts that needs to be processed, that will be in the unprocessed form, that is raw facts or raw elements. So I can take anything as a data. It could be either image, text, numbers or any audio or video file. So when it comes to the information, that is nothing but what? It is a processed data, that is known as information. It has a meaningful context. So that is regarding data and information. When it comes to the hardware and software, so hardware is nothing but it is a physical component of a computer system that we can feel and touch. So physical component of a computer system is known as hardware. So that comes under hardware. When it comes to the software, it is a set of programs or a set of instruction that will going to tell the hardware to do the task. So then what are the types of software we have? That is two types, application software and system software. Then what are the functional components of a computer? There you have to concentrate on four parts. So that is input unit, and then we are going to work with CPU, that is central processing unit. Under the CPU, again it is classified into three parts, that is control unit, ALU and then registers. So those three are the subunits of a CPU. Then it comes to the memory unit. Memory units are mainly used to store the data. Which is immediately required for the processing. Then what are the types of memory? That is primary memory and secondary memory. So when it comes to the output unit, it could be a combination of one or more output devices. So it will going to connect the computer to the external world. But when it comes to the input device or input unit, at that time it will going to connect an external world to the computer. That is the difference between input unit and output unit. So then what are the examples of this output unit? So we can take printer, plotter and monitor as an example for the output devices. So this is what I have discussed in the previous session. So in today's session, I will be discussing regarding evolution of a computer. So we all know that computer is mainly evolved or mainly invented for the purpose of calculation. So computers are nothing but for the calculation that will going to make our life easy, and in order to solve a complex problem, we are going to use the computer. So now we'll see how the computer got evolved from stage to stage. So when it comes to the first thing, so mainly computer has been invented for the purpose of calculation. Then which is the first calculating machine? That is abacus. So if you see here, when it comes to the evolution of a computer, the first calculating machine which was invented approximately 4,000 years ago by the Chinese, that is abacus. So if you see here, you can get to know that approximately 4,000 years ago, Chinese has been invented this abacus, which is mainly for the calculation purpose. So it is used for counting and calculating. Then how this abacus has been made? So it was made with the help of this wooden frame and metal rods and wooden beads. So these are the materials that they are going to use in order to manufacture this abacus. So then why we are going to use this abacus? That is mainly for the purpose of counting and calculating. Then what are the operations that we can perform? That is addition, subtraction, and later it will be invented for the division as well as the multiplication. So when it comes to the evolution of a computer, here you have to learn what you mean by abacus, then what are the materials that we are going to use in order to manufacture this, and what are the operation it will going to perform, whether addition, subtraction, multiplication or division. So that and all you have to concentrate. And you can also see the image of abacus. So now we'll see which is the next calculating machine, that is Napier's bones. So Napier's bones has been evolved just after the abacus. So when it comes to the Napier bones, it was invented by the Scottish mathematician. His name is John Napier. So he invented this Napier bone. Then how it will be used and what are the materials they have used in order to work with this, that we are going to see now. So here in the early 17th century, John Napier, he is a Scottish mathematician. So he invented a calculating tool. So the purpose of this Napier bones is mainly for the calculating purpose, that is used as a calculating tool that is named as a Napier bones. So it is mainly based on the manipulation of the rods along with the printed digits. So if you look into this image, here you can see that here we have a rods along with the printed digits on this. So this is mainly used for the calculation purpose and manipulation purpose. So the rods were made of bone or ivory or wood or metal. Then what are the metals or what are the things they have used for the manufacture of this Napier bone? They have used bones, so that it will be named as a Napier bones. Okay, so it could be made either by making use of this bone or ivory, then wood or metal. Then how it will be configured? So that is, it has a set of consists of 10 rectangular blocks. So it has 10 rectangular blocks. So 10 is nothing but they are going to consider from 0 to 9, and it was like dice. So the set consists of 10 rectangular box with multiples of different digits on each of the 4 sides. So if you consider this one number or one digit, so it has 4 sides. So it has 4 sides. In each side we have different numbers. We have different numbers that will be used for the calculation purpose. So who invented this Napier bone? It was invented by the Scottish mathematician. His name is John Napier. So that was invented in the 17th year. So mainly it is called as a Napier bone. So this is mainly called as Napier bone. It was made by making use of bone, ivory, wood or metal. So it has 10 digits from 0 to 9. It has in all the 4 sides, it has different number which is used for the calculation purpose. The next counting machine is that is slide rule. As the name indicates, ruler in the sense there will be numbers, and we are going to use that for the calculation purpose or for in order to find the distance. So based on that, you can see here the slide rule was invented by William Oughtred. He is the one who invented this slide rule, that is William Oughtred. Then how this slide rule will going to work? So it is based on the principle that actual distance from the starting point of the rule is directly proportional to the logarithm of the numbers printed on the rule. So in this you have to just remember which is the rule they are going to apply for each calculation method. So from one method of calculation is differ from another method of calculation. So in this, they are going to use the bones, rods and all. So in all four sides, it has a values, and based on that, they are going to calculate. But when it comes to the abacus, at that time, they are going to use the beads. So that beads will be used for the counting purpose. So each method of calculation is different. So how this slide rule will going to work then? So there will be some starting point. So from that starting point, it will be directly proportional to the logarithmic of a number. So the logarithm of the number which is printed on the rule. So here you can see the image of this slide rule. So it will be, when it comes to the starting point, that will be directly proportional to the logarithm of a number printed on the rule. So based on this context or based on this principle, this slide rule will going to work. So then the slide rule is embodied by the two sets of scales. So as we all know that rules in the sense scales will be there, right? The slide rule is embodied. That means that is connected by the two sets of scale that are joined together with a marginal space between them. So if you look into the second picture, here they have merged or they have embodied two rulers or two scales that you can see on this image. So this is how the scale rule will going to work. So here they are going to consider the starting point. From that starting point, it will be directly proportional to the logarithm of a number which is printed on that rule. So this is how this slide rule will going to work. So based on this, they are going to get the calculation done. Next is that is adding machine, pascaline. So if you see here, that is adding machine, pascaline. Then who invented this pascaline? That is important for 1 mark question. Who invented pascaline? So it was invented by a French mathematician by the name called Blaise Pascal. He is the one who invented this pascaline, that is adding machine, when he was 19 years old. So at the age of 19 years, a French mathematician called by the name of Blaise Pascal. So he is a person or a mathematician, is a French mathematician, that is Blaise Pascal. When he was 19 years old, at the time he invented this pascaline. So he invented this pascaline so that it will be named as a pascaline. His name was Blaise Pascaline, but it was invented and named as a pascaline. Then how it will going to work? So we'll see now. The pascaline is known as the first mechanical and automatic calculator. So very important. So what is the another name for the pascaline? That is, it is the first mechanical and automatic calculator. So that is the name of this pascaline. So the pascaline was a wooden box. So then how it will be made and how it will be manufactured? It was a wooden box that could only add and subtract by the means of series of gears and wheels. So if you look into the image, there will be gears and wheels. So based on that, it will going to add and subtract. Then what are the operations that can be done by making use of this pascaline? That is addition and subtraction. So there will be wheels and gears. So based on that, it will going to work. So if you look into it, it has several wheels. So when it comes to the first wheel, it will get revolved. So when it reaches to the end, at that time the control will be moved to the second wheel. So this second wheel gets started revolving. So it will get started rotating. So when it reaches here, at that time the control will be moved to the next one. So this is how the wheels and gears will be used in order for the addition and subtraction purpose. So that is, it had a box with a movable wheels. So these wheels can be movable. So then what I can call for that as? That is dials. So I can call these wheels as a dials. So when each dial, that means when each wheel rotated one revolution, it would then turn to the neighboring wheel. So as I discussed earlier, so when it rotated or when it revolved one side, so that control will be moved to the next wheel or next dial. So this is how the pascaline will going to work, and it will be mainly used for the addition and subtraction purpose. So here you have to remember one thing, the French mathematician. His name is Blaise Pascal. When he was 19 years old, he invented this adding machine, that is pascaline. Then what is the name of this pascaline? That is, it is a first mechanical and automatic calculator, because when it reaches to the one revolution and it will move to the next one, that is automated. So no human intervention is required. So that is the main thing, that I can call this pascaline as a first mechanical and automatic calculator. So it has wheels and gears, and I can call that movable wheels as a dials. So this is how this adding machine, that is pascaline, will going to work. So next we have a Lebanese calculator. So then who invented this Lebanese calculator? He is a mathematician by the name Gottfried Leibniz. He built a calculator in the year of 1650. So what are all the operations that I can done by making use of this calculator? That is addition, subtraction and multiplication. That is multiply and divide the numbers. So if you look into the image of this Lebanese calculator, so this has the ability to add, subtract, divide and multiply of a given number. So it was invented by a Gottfried Leibniz. So next we have a Jacquard Loom. So if you look into the name of a machine, so it is integrated by the name of an inventor. So if you look back to the previous one, there we have Lebanese calculator, and it was invented by Gottfried Leibniz. So when it comes to the pascaline, the inventor name is Blaise Pascal. So in the earlier age, they used to add their name for the machine name. So in the same way, Jacquard Loom, which was invented in the year 1801 by the person called Joseph Mary Jacquard. He invented this Jacquard Loom. So the Jacquard Loom was invented by a person called Joseph Mary Jacquard, and it is a powered loom that is used punched wooden cards. So here you have to understand one thing. Before the invention of the input devices, punch card were used as a input device. So it will going to take the data which is given by the user as a input device. So this punched wooden cards will be used as a input. So that means it will going to take the input from the user. So based on that input, it will going to process, or it will going to calculate. So to automatically view incredibly detailed pattern, so that patterns may include pictures and text. So for example, I want to print this pattern. At the time, what I am going to do? So by making use of this Jacquard Loom, I am going to give this pattern as a input in the form of this punched wooden cards. So I have a wooden card. So I am going to give the input pattern like this as an input. So by making use of this Jacquard Loom, it will going to view. It is like weaving cloths and weaving saris and printing the design on that saris and all. Like that, it will going to work. So it will going to print and store the data permanently. That means we cannot erase, or we cannot rewrite, or we cannot overwrite, in the sense what? It will be read only. So you can see here, so this can be taken as the first read only memory device, because I am going to have the some details pattern of text and images. So that will be given as an input for the Jacquard Loom. So by making use of this weaving method, it will going to print, or it will going to view that data on the machine. So it will be considered as the first read-only memory device. So very important. What is the another name for the Jacquard Loom? That is first read-only memory. So why we are going to call that as a read-only memory? Because by making use of this punched wooden cards, I am going to view, or we are going to print that incredible designs and patterns on the machine. So we are going to get the output by making use of this Jacquard Loom, so that we can call that as a read-only memory. So we cannot erase, or we cannot rewrite it or overwrite it once it is done. So that is the usage of this Jacquard Loom, and it was invented by Joseph Mary Jacquard. So now we'll see about difference and analytical engine. So when it comes to the difference and analytical engine, where the actual invention of the computer get started. So So in the early 1820s, the English mathematician by the name, what is the name of that person? It's a great Charles Babbage, who has designed a computing machine that is called as difference engine. He has invented two machines. So there will be two machines which was invented by Charles Babbage. The first machine I can call that as difference engine. So the name of a first machine which is invented by the Charles Babbage is difference engine. So here we are going to say that easily who is the father of computer. We are going to say as Charles Babbage. But we should not forget and we should be thankful to the people who invented all these things. Because of all these people's invention, so today we are living in a digital world. So that is the main thing about this Charles Babbage. He has invented two machines. The first machine is difference engine. So then how this difference engine will going to work? This machine was used in the calculating and printing of simple mathematical tables. So why we are going to use this difference engine? That is mainly for the calculation purpose. So it includes addition, subtraction, division and multiplication. Along with all the calculation, it will going to print some simple mathematical table. So that is the main advantage of using this difference engine. So which was invented in the year 1820 by the mathematician called Charles Babbage. So this is regarding first machine which is invented by Charles Babbage. So when it comes to the second machine or a second device, that is in the 1830s, he designed a second computing machine that is known as analytical engine. So what is the second machine he has invented? That is analytical engine. So this machine consisted of 5 units. So this consists of 5 basic units. So which become the basic principle for the development of the modern computer. So now whatever we have as a computer that consists of 5 units or a component which was designed as a analytical engine by the person Charles Babbage in the year of 1830. So in the year of 1820, he has invented a first machine. That machine is difference engine. Difference engine. And when it comes to the 1830, he has invented his second machine that is known as analytical engine. That is known as analytical engine. So it is the second machine which is invented by Charles Babbage. So when it comes to the difference engine, that will be mainly used for the calculation purpose. Along with that, it will going to print some of the simple mathematical table. So but when it comes to the second machine which was invented by the Charles Babbage, that is in the year of 1830, that I can call that as analytical engine. So this analytical engine has consist of 5 units. So that units will be considered as a basic principle of the development of modern computers. So this is regarding analytical engine and difference engine. Then why we are going to call this Charles Babbage as the father of computer? Because he is the one who invented this difference and analytical engine that is mainly used as the principle for the development of this modern computer. So that we are going to call the Charles Babbage as a father of computer. So then who is the father of computer science? That is Alan Turing. So as I discussed in the previous session, if I want to work with a computer system, then there must be a usage of hardware and software. So softwares are nothing but what? That is a set of instruction that will going to tell the hardware to do some task. Then we have here analytical engine is there and difference engine is there. So in order to get the beneficiary by this engines, or it has to be converted as a modern computer, then there must be 5 units. Right? So there must be like software also. Then who has written a program for this analytical engine? That is Lady Ada Lovelace. So she is the first programmer, one who written a programming for the analytical engine. So Lady Ada Lovelace was the first computer programmer. So a very important question for 1 mark question. So who is the first programmer? That is Lady Ada Lovelace. She was the first person or a first programmer who designed a program for Charles Babbage's analytical engine. So this Charles Babbage has invented and manufactured this analytical engine with the basic principle of modern computer. Then who has written the code for that one? That is Lady Ada Lovelace. So she is the first woman or a person who has written a program for the analytical engine. So we must be thankful to all these people, one who made our life so easy. And in order to solve the complex problem, we are going to use the computer. So that is because of all these people's struggles. Okay. Yes. After that, in 1890, so Hollerith tabulating machine. So this is another machine which was invented by whom? That is an American called Herman Hollerith in the year of 1889. In the year of 1889, a person called Herman Hollerith, he invented a counting machine to count the population of USA. So in order to count the population of USA, the American, his name is Herman Hollerith, he invented one machine. So what is the name of that machine? That is Hollerith tabulating machine. So here you can see the image of that one. So mainly this was invented in order to calculate or in order to get to know the population of USA. So this electronic machine is able to read the data and information on the punched cards and process it electronically. So as I discussed, punch cards were used as an input device. So whatever the data and information that I am going to give as an input, with the help of this punch card, it will going to receive or it will going to connect an external word to the computer system or to any electronic machine. So by making use of this punch cards, we are going to give the data and information, then it will be processed. After that, it will going to give the resultant. So in the same way, this electronic machine will going to read the information on the punched cards and process it electronically. So it will going to process it electronically. Here you can see the image of this Hollerith tabulating machine, which was mainly used for the concern of in order to calculate the population of a USA. So Herman Hollerith was the founder of the company. So this Herman Hollerith tabulating machine was invented by the person called Herman Hollerith. He is the founder of this company, which is now named as IBM. So we all are familiar with a word called IBM, right? So it was founded by the person called Herman Hollerith. So this is mainly used for the calculation purpose. So now we are in the digital era. So before that, we have several types of calculating machine. So from the abacus to till date, we have several kinds of calculating machine. So the main purpose of inventing or evolution of this computer is mainly for the purpose of calculation. So that could include addition, subtraction, multiplication, division and all. But the methodologies are different. So this is all about evolution of a computer system. So what and all we have discussed in today's session, there you have to consider from the abacus to till date. So the first evolution of a computer started from the counting machine called abacus. Later we have Napier bones, then slide rule, then adding machine that I can call as a pascaline, and then Lebanese calculator is there. Then we have Jacquard Loom, then difference and analytical engine, very important, where the actual invention of the computer started here, that is difference and analytical engine. It was created by the great person called Charles Babbage, so that we are going to name him as a father of a computer. Then later in 1833, the first programmer, that is Lady Ada Lovelace, she has written a program for analytical engine. And in 1890, that is Hollerith tabulating machine, so which was created by Herman Hollerith for the main purpose of in order to find the population or in order to count the population of USA. It's all about today's session. So in the next session, I am going to discuss regarding the generation of a computer. So until that, keep learning, keep on growing. Thank you very much.